everyone. Now we will talk about concepts of thermochemistry. So what is enthalpy? Enthalpy is a measure of the total energy of a system. It includes both the internal energy, the energy contained within the system, and the energy needed to make room for the system by displacing its surroundings. This is represented by the term PV. Pressures times volume. In simpler terms, enthalpy helps us understand how much heat energy is involved in a system at constant pressure, which is common condition in real-world processes. Understand the formula. Enthalpy represented with the formula H equals U plus PV. U stands for internal energy, which accounts for the kinetic and potential energy of particles in a system. P is the pressure exerted by the system, and V is the volume. Of the formula shows that enthalpy includes both an internal energy of the system and the work done is displace its surroundings. Enthalpy change represents the difference in enthalpy between two states of the system. When energy is absorbed or released during a process, such as a chemical reaction or phase change, the enthalpy changes. For example, when a substance undergoes a chemical reaction, the enthalpy change tells us if the reaction releases heat, exothermic, or absorbs heat, which means endothermic. Types of process involving enthalpy. Endothermic reactions. These reactions absorb heat from the surroundings. Because heat is absorbed, the enthalpy of the system increases. So delta H is positive. A common example of this is the melting of ice or boiling of water. While the exothermic reactions, these reactions releases heat to the surroundings. In this case, the system loses heat, so the enthalpy decreases and delta H is negative. Combustion reactions such as burning wood or gasoline are examples of exothermic reactions.
Thermochemical equation, a balanced chemical equation that displays the magnitude of the enthalpy value associated with the process. Thermochemical equation is a balanced chemical equation that includes the change in enthalpy of the system during a reaction. It shows not only the reactants and products but also the amount of heat released or absorbed during the process. For example, this chemical equation, it has change in enthalpy at negative 890.4 kilojoule per mole. In this case, the negative sign change in enthalpy indicates the reaction is exothermic or release heat. The number negative 890.4 kilojoule per mole represents the amount of heat released when 1 mole of methane reacts completely with oxygen. The enthalpy change is typically expressed in kilojoule or calories per mole of reaction. Is a thermochemical equation is different from a chemical equation? It includes the amount of heat energy involved in a chemical reaction, whereas a chemical equation only shows the reactants and products involved in reaction. And because thermochemical equation includes the enthalpy change of reaction. In other words, a thermochemical equation shows the heat energy that is either released or absorbed during chemical reaction. So we have example. Propane reacts with oxygen gas to produce carbon dioxide and water as shown in the reaction below. How much energy in kilojoule will be released of 500 kilograms of propane is burned in air? So we have our chemical balance equation here, and our change of enthalpy is equivalent to negative 221 kilojoule, which is negative, so it means released. And then first we're going to convert our 500 kilograms to grams, and then grams to mole, and mole to our change in enthalpy, which is negative 221 kilojoule. And then multiply or divide. So the energy released when 500 kilogram of propane burned is approximately 25.2 million kilojoule, or 2.52 times 10 to the power of 7 kilojoule. Example number 2. How much heat is created by 79.2 gram of O2? So we have our balanced chemical equation, and our change of enthalpy is negative 840.4 kilojoule. And then same process of our example number 1, but this is grams now. So we're going to convert grams to moles, and moles to our change of enthalpy, which is negative 840.4 kilojoule. So our answer is negative 1039.995 kilojoule. Enthalpy or formation is the change in enthalpy, heat content, that occurs when 1 mole of a substance is formed from its elements in their standard states. Under the standard condition is 298 K and 180 amp pressure. The standard states of an element is its most stable form at 298 K and 180 amp pressure. The enthalpy of formation represents the energy released or absorbed when a compound is created from its constituent elements. When a compound forms its element, the energy change associated with this formation can either be exothermic, releasing energy, or endothermic, absorbing energy. The enthalpy of formation is used in Hess law, and in calculating the enthalpy change of chemical reaction from known values of the enthalpy of formation for all the reactants and products. His law states that the total enthalpy change for a chemical reaction is the sum of the enthalpy changes of the steps into which the reaction can be divided. Because enthalpy is a state of function, the overall enthalpy change is the same regardless of the path taken from the reactant to products. An example of enthalpy is the formation of water from its elements in their standard states. In this reaction, hydrogen gas and oxygen gas react to form liquid water. The enthalpy of formation of water is the heat change that occurs when 1 mole of water is formed from its elements in their standard states. An explanation of this is the standard states of hydrogen is H2 gas, and for oxygen it is O2 gas. The enthalpy of formation is measured under standard condition. In this case, the enthalpy of formation of water is negative 285.8 kilojoule per mole, which means 285.8 kilojoules of energy is released when 1 mole of liquid water is formed from its elements in their standard states. The thermochemical equation is important because it not only shows the reactants and products of a chemical reactions but also includes the heat change, indicating whether the reaction is exothermic or endothermic. This helps understand the energy flow during reactions, which is crucial in industries and research. The enthalpy of formation represents the heat change when 1 mole of a compound is formed from its elements in their standard states. It serves as the reference for calculating the enthalpy change of a reaction using His law, which allows for determining the overall heat change in complex reactions. Knowing the enthalpy of formation helps predict whether a reaction is thermodynamically favorable and estimate the heat observed or released. Together, these concepts are essential for designing energy efficient process and understanding energy change in chemical reactions. This enthalpy of formation is important because it helps in calculating the enthalpy changes in chemical reaction and is used to determine the overall energy changes during reaction. Enthalpy of formation provides a way to quantify the energy change associated with the formation of compounds, and it is a fundamental concept in thermochemistry. Thermochemical equations are helpful in calculating heat energy involved in reaction, designing energy involved in reactions, assigning energy efficiency process, and understanding the energy relationships in chemical system.
First law of thermodynamics. The first law of thermodynamics, also known as the law of energy conservation, states that energy cannot be created or destroyed in an isolated system. The total energy of a system is constant, although it can change form such as from heat to work or internal energy. The law can be stated as an equation, where delta U equals Q minus W. Delta U means change in internal energy of a system will be equal to energy transferred from the system as heat minus the energy transferred or from the system as work. These all are measured in joules. Because of this law, we can outline a few different types of processes that can occur. If a process occurs where there is no change in volume for the system, that means that no pressures volume work can be done on or by the process. So work is zero in such a case. Delta U equals Q, and any change in internal energy must be the result of heat transfer, in or out. This will be called an isovolumetric process, meaning no change in volume. Example would be a bomb calorimeter, where a combustion reaction produces a change in temperature but the rigid walls results in no change in volume. If there's no change in the temperature of the system, there cannot have been any change in any internal energy of the system. Since these two values are proportional, delta V will be 0, which makes Q equal to W. This means that any heat transferred into the system is used by the system to do work rather than increasing the internal energy of a system. This is called an isothermal process, meaning no change in temperature. An ideal version of a car engine would be an example of this, as the pistons off to convert all the heat energy from the combustion reaction directly into expansion work that moves the car. If there is no heat transferred, Q will be 0. There's no heat transferred, Q will be 0 and delta U will equal negative W. This means that the internal energy of a system changes as the result of doing work on its surroundings or the surroundings doing work upon the system. Such as process will be called an adiabatic process, meaning no heat transfer. We can see this in certain processes in Earth's atmosphere, as masses of air change position due to pressure differences. And if Q and W are both zero, meaning there is no heat transfer and no work done, there can be no change will internal energy, and this must be an isolated system. So now let's review. Delta U equals Q minus W. When the heat is observed, the Q will be positive. So when the heat is released, Q equals negative. And when the work done by the system, W equals negative. When the work done on the system, W will be negative. Q and W can also equal 0. So that's all, and make sure you use the correct sign. We will proceed to the given example. 100 joules of work is done on a system internal energy and increases by 74 joules. How much energy is transferred as heat? That the formula that we need to use is Q equals delta U plus W. So now this is the answer of the given questions or the given problems. And now, this is your time to answer the following problems. So the problem is a sample of gas does 150 joules of work against its surroundings and loses 90 joules of internal energy in the process. Does the gas gain or lose heat? And how much? So this is the answer.